We're back here with Cecile and James for part 2 of the Class API and Class API Azure Provider. On the part 1, we created the cluster, the management cluster, and create one cluster on Azure. Now, Cecile, how can we dig more on that, and how can we show the day 2 operations? Okay, now they have this cluster in production, and they want to change something, how that's going to work, how easy it's going to be that, compare with the past, compare with AKS engine and other things. And I think that's the great advantage that we bring with Class API.
Yeah,
All yours.
So this is, thanks.
Welcome.
This is actually one of my favorite parts to show because it really shows like how cool this this concept is. But so if you remember from the previous part, we had our 3 clusters, the one that we just created, and then the other 2 that we had before. And so let's say, I changed my mind. I actually don't want workload cluster 1 anymore. And so what you can do is here, you just use the same gestures that you're used to with kubectl, and I can do delete cluster, and I'm going to do delete workload cluster 1. And I'm going to do
no.
And so, yeah, I know it's exactly how I felt. So you're actually doing this against the workload cluster or the management cluster? Which one is like?
So,
what's our context here?
So my kubeconfig is pointing to my management cluster right now, right? And that's what the management cluster is really all where you do all the lifecycle operations to manage your cluster infrastructure, right? So here I'm pointing to the management cluster. I'm saying, what clusters do I currently have? Okay, delete that one and don't wait for completion. So now if I do get clusters, it will show me hopefully that one is deleting. There we go. And so it's going to go in and delete all the Azure resources that are associated with that cluster. And once that's completed, that will disappear.
So
if
you
I
will
do get
no longer
machines,
have machines up in Azure then, right? Like, be careful doing this on your own.
Well, yeah. So this is a test cluster, so I didn't get too attached to it. But, be careful when you delete things, as always. But so that's kind of cool, but it's not that cool.
Interestingly, with the deleting and the provisioning of things, since these are all components inside Azure, we could set up RBAC rules on some of these commands and things so that we could say, only admins have the ability to delete clusters, and this other group of folks who do upgrades and things, they can't delete clusters. They would have to be a different part of they'd have to log in as an administrator. So that's kind of the powerful aspect that we get by using Kubernetes primitives here to deploy these things.
Absolutely, yes. And yeah, I've only been doing get, but you can do all the commands that you're used to, with describe cluster. You can describe, you can get, you can delete. So, this shows me my spec for the cluster, what it currently looks like. And then the status here is what it tells me about the current state of the world, right? So it's telling me that it's currently in provision phase, the infrastructure is ready, and all 3 control planes. Oh, sorry, that's the failure domains, but the control plane is ready. I only have 1 control plane currently, which actually is not that great. So I think I want to change that. So, okay, there we go. I only have my 2 clusters remaining. And so I want to go ahead and scale up that control plane. So I'm going to do edit, and then I'm going to pass in the name. So by the way, KCP stands for kubeadm control plane, and that's one of the control plane providers. kubeadm is another subproject of SIG cluster lifecycle, and it's what Cluster API is built on top of for bootstrapping, at least for that provider. And it's a tool that was built that really simplifies getting from a machine, like a unit of compute, to Kubernetes nodes. So it runs on the nodes and it bootstraps the Kubernetes nodes.
Does all the secret management and
all
making
the
sure, yeah.
Exactly, yeah. So Okay, and then so I'm going to do edit. And then here, what do you think I'm going to do?
So what you're doing here is you're actually editing the YAML that is on the management cluster. And if you're upgrading the nodes, then you're probably going to bump a value in here somewhere.
Right, so here right now, I said I want to scale up my control plane replicas, right? Because I only have one replica of that control plane. And so I think for HA, I want to have 3, right? At least, maybe 5, but let's start with 3. So here I'm just going to edit and change that 1 to a 3, and I'm going to save and quit. And it's going to tell me your KubeADM control plane, it was edited, so that's great. And so now if I do get KCP, it's going to tell me like, okay, now it has 2 replicas. It's actually going to scale up to 3. So if I do get machines, I have this new replica that's creating for that cluster. And it's going to take a minute. It has to provision, the VMs and initialize or join the node to the Kubernetes cluster. But after a few minutes, I should have 3 control planes. Does that make sense?
Yeah. So you edited the YAML directly through, kube control, but I could modify the YAML that I had generated initially, that we generated last week or in the last episode, and just change that number and do a kubectl apply. Is that right?
Yeah, you could. The only thing I would say with that is make sure you haven't changed anything else in the meantime, because if you reapply that initial YAML and you've changed other stuff, you might revert to your other changes. But you can totally do that. And like, instead of doing an edit, you can apply the YAML on top and it will like apply the difference. And that's actually really powerful if you're thinking of doing, GitOps, where you have like a version control of your spec, and then you can apply those YAMLs and like check it with checking them into codes. That's pretty cool.
Yeah, I was going to exactly ask that. In production, you're going to have like a GitHub repo, like a Git repo where you're going to have all those YAML files that will be like your source of truth, where your configuration is, or the desired state. And every time that you change something, will be applied on like a CI/CD, will be applying, or GitHub Actions or something. Just keep in mind that we play here more like a demo, but like in real life in production, you need something like that.
All right, so here if I do describe, this shows a pretty good overview of what's going on. So it's telling me my control plane is scaling up. It's scaling up to 3 replicas, and right now I have 2. And so it's going to wait for the second machine to join before starting to create the third machine.
Yeah, I like now that you moved to Clusterctl. Then you're pretty much doing the same thing. You're looking, but Clusterctl looks like you have more different way to describe, because you're getting information from multiple resources on the management cluster. Is that correct? Like when you do a describe here, you're describing multiple CRDs on the management cluster.
Yeah, and so this is kind of convenience that was added, by one of the developers in the Cluster API project, because we kept doing that. The other thing you can do is to get Cluster API, which will actually show you all the resources that are in that Cluster API group, which can be overwhelming, especially when you have 3 clusters at the same time. But it's good to learn about the different resources that exist. So I have
another little tip.
Yeah.
So many little things here.
And so this is like all the Kubernetes resources. And so this clusterctl, it's a command that is really Cluster API specific, because it shows you not only the resources, but also how they're related to each other with that tree setup here. And one thing we've considered actually in the project is turning this into a kubectl plugin. So you can have you can do kubectl cluster API get or describe cluster. That hasn't happened at the moment, but it might happen in the future.
That's a good idea. Yeah.
Cool.
So let's where we're at. Okay, it's still scaling.
Yeah, so here we can see that it's waiting for the bootstrap data. That's a new value that we saw. And so what's happening here is the cube or the bootstrap provider is actually going out and getting all the certs and getting that all aligned properly and then handing it off to the Azure provider. And the Azure provider will then take that and actually create the machine and put the certs in the right locations for the cluster. Did I get that right?
Correct. Yep, exactly. And so that's the new control plane that's provisioning. So I think maybe
for the second, day two operations, they have to understand the YAML file, because after the initial bootstrap, they now have to maintain those YAML files. Then they have to understand that the control plane is one thing, and then the worker nodes another thing. If you mess with those things and scale the control plane, you'll be completely different. Have to understand the difference between pools and.
Absolutely, it is a learning curve. But I think it's the same as Kubernetes pods and deployments. Like, you have to understand how the deployment spec works in order to configure your deployments and create new deployments, etc. One really useful thing for this is kubectl explain. I don't know if you're familiar with it, but you can basically describe any Kubernetes object. So you can also do explain pod, and that will tell you, basically give you all the information about the pod object. But here, if we're looking at KCP, which is kubeadm control plane, which is the thing I just modified earlier to add replicas, it tells me all the fields in there. So API version, kind, metadata, spec, and status. So spec is the desired state, and then status is the observed state. So if I want to explain KCP, it's dot spec. Right, so this is all the fields that are in spec that are available to modify. And so this is the one that I modified here. And so it's telling me this is the number of desired machines, defaults to 1, which is what I had initially. And when you're using stacked etcd, you can only have odd numbers for quorum. And so, 1, 3, 5, etc. So this is a really useful tool for learning about this if you're just getting started and just playing around with the different fields and seeing what can be modified, what can be configured, etc.
Yeah, I think that's great. One thing that people are going to ask for production is that V1 Alpha 3. Can you explain a little bit that version and how that's?
For sure. Cluster API, the project, is following similar process as Kubernetes version graduation. And so it started in V1 Alpha 1. And so far we've released 3 alpha versions, Alpha 2 and Alpha 3. Alpha 3 has actually been around for a long time, and we're actually about to release V1 Alpha 4 next week. So by the time this video is published, it might already be out. And what it really means is that it follows the alpha requirements of Kubernetes in terms of APIs. What's important to know about that is that it technically means that the API can be changed or removed at any point in time. And that's really allowed the project to grow fast as it was first starting, and move fast, break things. But we're starting to get to a point where we're stabilizing the APIs, and we haven't had any breaking changes that didn't come with conversion for backwards compatibility in over a year. So we've actually started a discussion in the repo for graduating Cluster API to 1.0 and beta. And so what we're doing at the moment as a project and as a community is we're, after we get V1 Alpha 4 release, which is primarily stability and iterative, so no big new features, we're aiming on the what they're doing. There's a lot of work going on with the user experience right now, especially like all those objects that I showed you. That can be a bit overwhelming, having all those different objects. So there's a proposal going on called Clusterctl, which aims at having a single object which defines a cluster stamp. So you can reuse the same cluster flavors across your clusters if you want multiple clusters that look the same. So there's things like that going on, and hopefully like the project will get closer to beta. What this is discussing is the possibility of getting the first beta release out for KubeCon US at the end of this year, so pretty soon. But yeah,
it's a good time to get started, I think, to get involved with the project. And
yeah, for sure. And I think a lot of the reasoning behind this discussion when it started is, it's technically alpha, but we've already been treating it as beta because we are supporting our APIs for over a year, which is a criteria for beta. So right now, even though we're in Alpha 3, we still have Alpha 2 supported. And as soon as we move to Alpha 4, we'll still have Alpha 3 supported, which has been around since last year. So, and there's conversion webhooks, which allow you to move from one version to the other without any breaking changes. So.
Yeah, I think that's important because we are using it, as a company, using that already inside. Means that we are supporting that in some, instance, but that's great.
So yeah, so our cluster is all scaled up and we have 3 replicas ready. Let's take a look at what Clusterctl describe is showing us. All right, looks pretty good to me. So that's great. So maybe one more thing, when I first created the cluster, I created it in V1 19.7, which is not actually the latest patch for Kubernetes version 1.19. So I want to upgrade the Kubernetes version, which is a pretty common operation that cluster admins, I'm sure, are used to doing. So here, what I'm going to do is I'm going to say, okay, so I want to upgrade my control plane. So I'm going to do edit, same thing as I did before. And here I'm going to look for the version field, here 1.19.7. And I'm going to change it to the latest, which is 1.19.11. So that's all I'm going to do. One thing to note here is if you are using a custom image for your nodes, custom OS image, which comes pre-installed with the kubeadm and Kubernetes binaries, kubelet and kubectl, you want to make sure that you're updating your OS image at the same time so that you have the right binaries installed for that new version. But I'm not going to go into that right now because I'm using the default reference image, which is going to get updated for me. So I do this, and then yeah.
Go ahead, finish that thought, and then I'll.
No, I actually just realized I just edited the wrong one, but it's not a problem. I'm just going to change this one here. Sorry, go ahead, James.
Yeah, so I think that's an important aspect to maybe understand is the nodes that in the images of the VMs that we're deploying are assumed to have certain components on them as part of the deployment of those worker nodes. So you kind of build a VHD or an image for whatever kind of platform you're using. So that could be on Azure, or it could be an AMI on AWS, or vSphere has the OVAs. And so you build those, but they have to have a certain number of components on there, and a couple files in the right locations. Cluster API doesn't actually do that for you. You have to kind of make sure you have to kind of bring your own image.
Yeah, and that's actually one of the things that people who usually gravitate towards self-managed clusters actually require for their setups, because it allows a lot more flexibility, and allows you to secure your image according to your company's policies and etc. So it is a little more work, and I guess you have to manage that yourself. But at the same time, it provides a lot of flexibility on what exactly you want installed on that image.
Yeah, you can preload all sorts of things, like even the images for your application on that, so that when the node comes online, when you deploy a pod to it, it starts up pretty fast. So there's all sorts of like little customizations like that. And then there's Cluster API actually has a project to help get you started with that as well, called Image Builder. I don't know if we want to quickly show that here, but yeah.
Yeah. Yeah, so the Image Builder is a project also in SIG Cluster Lifecycle that is basically where all the image building stuff for Cluster API lives for all the different providers, and it also helps you build your own images, and has the base definition of the images that are used as reference images in the project.
Cool.
Yeah, I think this could be a reason that people want to create their own cluster and not use, like a AKS fully managed cluster. And also to have the same kind of cluster across multiple clouds or on-premise. And if someone is asking why those guys are doing this, why they're not using AKS or all the cloud providers, is exactly because we have use case for that. And the way that we manage it, if you have to manage your cluster, we need a solution where you can really have an option for day two operation. I used to do that with ACS engine or AKS engine long time ago, and I know how hard it is. It's just good for create the cluster, but to maintain the cluster is very hard, and the Cluster API is really helping on that.
Yeah, and that's really what we're trying to solve here, that problem of the day two maintenance of the cluster. So here we have the control plane, which is doing a rolling update so it's rolling 3 replicas to have the new Kubernetes version. So let's check what the nodes are like right now. All right, so yeah, so we have 4 nodes at the moment. So I think this node just came up. This is the node with the new version, and I still have my 3 other nodes with the old version. So it should start disabling, scheduling, and deleting the old node soon.
Okay,
and
yes.
then it
That's
will.
why we have 4 nodes here, which is kind of surprising because we defined 3 replicas earlier.
Right. So the way it does it is it will search by 1, so that you don't have any, you don't lose any availability. So it will create the new control plane with the new version or the new configuration. It doesn't actually have to be Kubernetes version. You can also change things like API server flags or like all sort of Kubernetes configurations on your control plane. And so it will create the new one, and then once that one is created, verify that everything looks good before proceeding to deleting the old one. And I've actually used that feature a few times where I was developing and trying something new, like a new configuration, and I happened to use the wrong configuration and break my control plane. So it would create a new one, and that new control plane was unhealthy. It was really easy to roll back and delete that new machine and then update the configuration and start again. And I didn't lose any machines in the process, which is pretty great. Okay, so there we go. So now we only have 3. Yeah.
I have a question here. What kind of operations do you see people doing, like updating the control plane of the classes, updating the work node that are worker nodes? What more? What they can do more with that? What kind of operation normally you see on like day two operations? You talk about the
Yeah.
node image, so you talk about.
So another thing you can do is like add a machine pool or machine deployment. And so let's show that. So right now I just have, so this is my other cluster, but on this cluster I just have one Linux machine pool, one Linux machine deployment, which is VMs based. And actually just that one is still showing as scaling up because I haven't applied a CNI to it. So you will see that if it explains it in the quick start. You need to install the CNI in order to have the container networking working properly, and then that will make the nodes go to ready. But what was I saying? So yeah, so you can add a whole different node pool. So let's say I have my Linux node pool and I actually want to add a Windows node pool. So I actually have this file here that is ready to be used that has the definition for a machine deployment that is based on Windows. So here you see OS type Windows. It has all the other required stuff, and I'm going to apply it. So I'm going to do the same gesture, kubectl apply, and then I'm going to pass in Windows pool. And I used the same cluster name to make sure it was added to that cluster. And it created the new machine deployment with the Azure machine template and then the kubeadm config template. So this is the infrastructure template, and this is the bootstrapping template. And so now if I do get machine deployments, I have my new Windows machine deployment that's scaling up. So it's creating the two replicas. So you can add node pools, remove node pools, change the node pools themselves. I can also edit this Linux machine deployment and add labels, things like that.
I mean, the machine deployment to be like a node pool, if you compare with AKS, correct?
Yeah, correct.
Yeah. And now you're creating like a hybrid Linux and Windows cluster. You like going deep now.
and you'll notice like you didn't need to know anything about Windows there. You were able to just use the same YAML, very similar YAML structure, added a couple values there, and you've added a whole nother set of machines that can operate completely different. So we did Windows there. You could maybe add GPU. You could do all sorts of different configurations with this, and that's that day two operation component that that folks are looking for when they come to this.
Yeah, so just to check in on my cluster status, it's added the two Windows nodes here, and then I still have two nodes. I have my two nodes ready with the new Kubernetes version, and it's progressing through the rolling update. So yeah, so that's kind of what you can do with your cluster. There's still a lot more things that I didn't have time to show here, but I'll let you explore and try it out. I think the best way to learn is to just create a cluster and try some stuff. Try to edit some of the stuff and see what happens. I hope you have fun with this, and I hope you get involved. You can reach out to us on the Cluster API Provider Azure Slack channel, on the Kubernetes Slack, or on GitHub, and we'll be happy to discuss or answer any questions you have.
Yeah, thank you, Cecile. James, you wanna say something?
Yeah, thanks for having us. That was fun. I even learned a couple things from Cecile there. So yeah, join us in the Kubernetes Slack. Anybody can drop in. It seems a little scary at times, but just come in and say hi. Everybody's very friendly and always willing to answer your questions. So hope to see you out there.
Leave your comment because we need need some feedback to know what we do next. And hope to see you on the next office hours and see you on Slack. Thank you, Cecile. Thank you, James. I appreciate your time. Talk to you soon. Bye-bye.
Bye.